Hello, good morning to all of you. We welcome you in this channel, and in continuation to the previous videos on electromagnetic induction, I have brought today some of the questions on self-inductance and mutual inductance. Right. So, inductance, what actually is inductance? This inductance is whenever there is a change in current flowing through a coil, it induces EMF in the same coil. Okay, whenever there is a change in the current carrying coil. Yes, we are talking about current carrying coil. In current carrying coil, if there is a change in current, it will induce an EMF in that coil, and that induced EMF will be called as self-inductance. Right? It will be self-inductance. Similarly, if a current carrying coil, the current is changing in that coil and nearby another coil is there, in that one induced EMF will be generated. So that will be called as mutual inductance. Right? That will be called as mutual inductance. So the same thing we are going to discuss today. Okay. So just I can tell you that in self-inductance, total flux, like we will be calculating total flux linked with the coil. Okay, the coil may be having N turns and phi is the total flux. So it is directly proportional to the change in current. Okay, the total flux linked in the coil is directly proportional to the current, and which we can write it as N phi is equal to Li. Okay, where L is called self-inductance. L is called self-inductance. Then we can find induced EMF is equal to minus d phi by dt, which we can write it as minus L di by dt. Okay? And the unit of self-inductance or mutual inductance, it is Henry. Okay? Henry, which is denoted by capital H. Okay, so if there is a long solenoid, in the case of long solenoid, which we can say that whose length is very large as compared to its area of cross section, so magnetic field B at any point will be constant. The magnetic field B at any point inside the solenoid will be constant. Okay, and self-induction of that solenoid can be given as mu 0 n square A by L. L is per unit length. Okay. Similarly, mutual inductance, when there will be a two coil, yes, so we can say that N2 phi 2 is proportional to change in current in 1. So the flux linked with the coil 2 is proportional to the change of current in coil 1. So we can write it as N2 phi 2 is equal to M I1. Okay, and here in this case also we can find out minus M di by dt as induced EMF as per Faraday's law, and mutual inductance M is equal to mu 0 N1 N2 A by L. So these are some of the expressions by which we will be in a position to find out the self-inductance and mutual inductance. Let us go for solving question number 1. Okay, right. So here it is given a circular loop of radius 0.3 centimeter. So suppose a circular loop is given and whose radius is 0.3 centimeter and lies parallel to much bigger loop of radius 20 centimeter. So we can say that another bigger loop is there, and in that same line center is lying, and its radius is 20 centimeter, which can be written as 20 into 10 power of minus 2 meter. 0.3 centimeter can be written as 0.3 into 10 power of minus 2 meter. Okay. It is also given that the center of the small loop is on the axis of the bigger loop. The distance between their center is 15 centimeter. So this distance is given as 15 centimeter, that is 15 into 10 power of minus 2 meter in SI unit. If a current of 2 ampere, yes, I is equal to 2 ampere flows through the smaller loop, then the flux associated with the bigger loop we have to find. Flux associated with the bigger loop. So in this case, first what we need to find out? We need to find out that the magnetic field which will be created in second loop, bigger loop. So what will be the magnetic field B? How we can find? So mu 0 I r square by r square plus x square 3 by 2, and here 2 also will be there. Okay, this is the formula by which magnetic field we will be able to find out mu 0 I r square by 2 r square plus x square 3 by 2, and this magnetic field will be in bigger loop. Okay, so we can find out the induced EMF the flux associated with the bigger loop. So it will be B dot A or B into A, and this A will be the area of smaller loop. Okay, and in this way we can substitute mu 0 is equal to, we can write 4 pi into 10 power of minus 7, so 3.14 into 10 power of minus 7 into current is also given to us as 2 ampere. Then R, what is R given to us for a bigger loop? It is 20 into 10 power of minus 2 meter. So 20 into 10 power of minus 2 is square, okay, IR square, divided by again 2, and here 20 into 10 power of minus 2 square plus 15 centimeter, that is given distance. So 15 into 10 power of minus 2, it is also a square, closed, and 3 by 2 here. Okay, and it will be multiplied with the area of what? Area of a smaller loop. So pi r square. So again 3.14 into 0.3 centimeter is the radius. So 0.3 into 10 power of minus 2 again is square, like this. So we will be able to find out the flux associated with the bigger loop, and this, when we will be solving completely, we will be getting 9 into 10 to the power of minus 11 Weber. Okay, solve it. Yes, certainly you will be able to solve it. So when we are solving all completely, we will get 9 into 10 power of minus 11 Weber. In case you do have doubt in calculations, just put a comment. Certainly I will reply with full calculations in front of you. Come to question number 2. In question number 2, it is given that if both the number of turns and core length of an inductor is doubled, keeping other factors constant, then its self-inductance will be. It means self-inductance. So what is the formula of self-inductance? L is equal to mu 0 n square A by L, right? Okay. Now it is given that another one it is. Suppose this is L1. Okay, L and L1. So both the number of turns and core length of an inductor is doubled. Number of turns is also doubled. Another one L1. So mu 0 A is common. N has become 2n. Number of turns is doubled and length is also doubled. Correct? Keeping other number of turns and core length. So this also will become 2l. So this will be given to us as 4 by 2 mu 0 n square A by L, which you can write as L1 is equal to 4 by 2 L. So this 2. So L1 is equal to 2 L, means twice. So you can say that the self-inductance of new coil, which will be made in by increasing the number of turns and by doubling the length, the self-inductance also will get doubled. Okay, self-inductance will get doubled. Next, the self-inductance of a solenoid of 600 turns is 108 millihenry. So it is given. What are the things we are given? We are given L is equal to 108 millihenry, right? Okay, and means which we can write as 108 into 10 power of minus 3 Henry, and number of turns it is given to us as 600. The self-inductance of a coil having 500 turns with the same length, same radius and same medium will be. So just now we have seen that the formula is mu 0 n square A by L of finding self-inductance. So we have to find if turns are changing in another case L1. In this case, number of turns. So new number of turns has become 500 and nothing has changed. Only number of turns have changed. Okay? Mu 0, A, L, all everything it is there. So this we can write it as 108 millihenry, or even if we can keep it, our answer also will come in millihenry only. 108 is equal to mu 0 A by L into n square. So n square is 600 square. Another case is there in which mu 0 A by L will be there, but n1 square, that is 500 square. Okay, dividing these two L by L1, so mu 0 A and mu 0 A by L both will get cancelled, and it will be 600 into 600 by 500 into 500, all zeros will get cancelled, right? And in place of L we will be putting it as 108, so we can find out L1. So L1 will be 108 into 5 into 5 divided by 6 into 6. So this so L1 will be equal to 75 what? Henry, millihenry. 75 millihenry. Then question number 4. The coil of an AC generator consists of 100 turns. Given N is equal to 100 turns of each wire each of area 0.5. So area is given as 0.5 meter square. Resistance of the wire, that is R, is given as 100 ohm. Coil is rotating in a magnetic field, so B is given as 0.8 Tesla, which is perpendicular to the axis of rotation, and at a constant angular speed, omega is equal to given 60 radian per second. We need to find the maximum EMF generated. Maximum EMF. So we know that EMF will be equal to NBA omega sin omega t. Okay? What it is? NBA omega sin omega t is the maximum EMF, means EMF. If maximum EMF, then sin omega t will be equal to 1. Okay? See here, perpendicular to the axis of rotation means omega t is 90 degree, sin 90 degree is equal to 1. So our maximum EMF will become NBA omega. You can substitute the value 100 into 0.8 into 0.5 into 60. So this 100 will be utilized to remove all these decimals here, and we will get 40 into 60, that is 2400 volt. Okay, 2400 volt. This will be the maximum EMF generated. Then maximum current, I0 is equal to epsilon 0 by R, that is 2400 divided by 100 ohm is there, so it will become 24 ampere. So the power dissipated to the coil is VI, power dissipated, P is equal to epsilon 0 I0, which will be equal to 2400 into 24, that is 57600 watt. Okay, which can also be written in scientific notation 5.76 to the 10 power of 4 watt. So this will be the power dissipated to the coil. Next question. Okay. So in this question, two coils C1 and C2 are placed close to each other, and we are being given a graph where this is I1 in ampere and the flux generated phi2 in Weber. So what it is given here, 5, 10, 15, and this is 0 only, and this is a straight line, then 2, 4, 6. Like this it is given. Okay. This is the figure given. So two coils C1 and C2 are placed close to each other. The magnetic flux phi2 linked with the coil C2 is varying with the current I1 flowing in coil C1 as shown in the figure. So we need to find the mutual inductance of the arrangement. Okay. So mutual inductance. First, let us find that mutual inductance. So we know that N2 phi 21 is equal to M2 I1, okay, or M21, mutual inductance of the coil due to current flowing in coil 1, okay, I1. Here M2 is not given, so we can write it as phi 2 only. Okay, phi 2 will be M21 I1, and from here M21 is equal to phi 2 by I1 we can write. And like suppose first one we can write phi 2 means 5 by 2. So this will be giving us as a slope. So slope itself will become mutual induction. Okay, mutual inductance. So in this way we can find. And second one, rate of change of current di1 by dt. So we know that if we find electromotive force EMF, so that will be equal to m di1 by dt. Okay, EMF induced in coil 2 will be the mutual inductance. It is proportional to the change in current. So m di by di1 by dt. Okay, because EMF is given to us as 100 volt, so we can write 100 is equal to m, and in place of m also we can write, that is, so di1 by dt. Further, di1 by dt is equal to 100 divided by m, and m is what? 5 by 2. So 5 into 2, so 20. So di1 by dt is equal to 40 ampere per second. Change in current is taking place as 40 ampere per second. So like this we solve questions mostly on inductance. In case any doubt, then please connect with me by putting comment in the video. We'll meet once again with similar kind of videos, and if you have liked it, then kindly share with your friends. Thank you very much.